Decimal and hexadecimal conversions for integers. Today I'm going to present an algorithm for converting decimal to and from hexadecimal integers. First, a little review. Decimal numbers are base 10. These are the numbers that we use in our daily lives. Hexadecimal numbers are of base 16, with each digit representing the value 0 through 15. An example is the RGB, or red, green, blue, code used to select colors in your art computer programs. With the place values, you can see that each placement corresponds to a power of the base. For decimal, we are working with base 10, hence 10 to the 0 power for digits, then going up 10 to the first power, 10 to the second power, 10 to the third power, and so on. This corresponds to, of course, ones, tens, hundreds, thousands. Similarly, with hexadecimal, we use base 16. So we start from 16 to the 0 power, 16 to the first power, 16 to the second power, 16 to the third power, and so on. For fractional numbers, negative base powers are used. As mentioned before, we will concentrate only on integers. Remember when we mentioned that each digit in hexadecimal representation has a value of 0 through 15? When writing hexadecimal numbers, the digits 0 through 9 have the usual value. For values 10 through 15, letters are used, usually written in uppercase. A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, F represents 15. Hexadecimal to decimal conversion. Doing this by hand, this is the easier conversion of the two. As I present the steps, you will see an example on the right hand of the screen. Let's get started. Step 1. Determine how many digits the hexadecimal integer has. Step 2. Assign a value of 0 to D. For our example, convert the hexadecimal integer 2a6 to decimal. 2a6 has 3 digits. Step 3. Multiply the first, leftmost digit of the hexadecimal integer by 16 to the power of n minus 1 and add the result to D. Subtract 1 from n. Go to the next digit and repeat this step until n reaches 0. With n equals to 3 in our example, the leftmost digit 2 gets multiplied by 16 to the 3 minus 1 power, or 16 squared. The result, 512, gets added to D. Subtracting 1 from n, we have n equals to 2. We'll multiply 10, which is represented by the letter A, by 16 to the first power. The result, 160, is added to D. Continuing on, decrease n to 1. Multiply our last digit, 6, by 16 to the 1 minus 1 power, which is essentially adding 6 to D. 6 times 16 to the 0 power. Decrease n to 0, and at this point we stop. We check the value of D, which is the result of 678. As I mentioned before, converting hexadecimal to decimal is easier. For the second example, convert the hexadecimal 3882 to decimal form. We can often do this in one step. The hexadecimal 3882 has 4 digits, so our decimal will have 4 multiplications. 3 times 16 to the third power, plus 8 times 16 squared, plus 8 times 16, plus 2 for the decimal form of 14,466. To remind ourselves, hexadecimal numbers are represented with 15 values, with A being 10, B being 11, C 12, D 13, E 14, and F 15. Decimal to hexadecimal conversion. This can be a little tricky, especially at first. Let D be the decimal integer. Step 1. Determine the biggest power of 16 that is equal to or less than D. Assign that power to n. This means our answer in hexadecimal form is n plus 1 digits. If you have a scientific calculator, you may take the integer form of the logarithm of d divided by the logarithm of 16. For example, convert the decimal integer form of 87 to hexadecimal form. Divide the logarithm of 87 by the logarithm of 16 and take the integer part. That is, just ignore the fraction. We find that n is equal to 1. There will be 2 digits in our answer, which is n plus 1. Step 2. Divide d by 16 to the nth power. Take the quotient, or integer part, of that division. This is your leftmost digit. Subtract 16 from the nth power from d. This is your new d value. Step 4. Subtract 1 from n. This is your new n value. For our example, n is equal to 1. Divide 87 by 16. The quotient is 5, which represents our leftmost digit in our answer. Then, 87 minus 16 times 5 gives the new value of d, which is 7. N is reduced to 0. Step 5. If n is equal to 0, stop. Whatever is left in d represents your last digit. Do not forget, if the digit is 10 through 15, use the appropriate letter. Otherwise, keep on repeating steps 2 through 4. In our example, since n is equal to 0, d has the value of 7, and that represents our last digit. In our conversion from 87 in decimal form to hexadecimal form, our answer is 57. Let's try another example. Convert 4078 from decimal to hexadecimal. Determine the number of digits. By dividing the logarithm of 4078 by the logarithm of 16 and taking that integer part, that result is 2. There will be 2 plus 1, or 3 digits in our answer. Using steps 2 through 4, we start with d is equal to 4078 and n is equal to 2. The quotient of 4078 divided by 16 squared is 15, which is represented by f in hexadecimal form. Our leftmost digit is f in our answer. The new d is 4078 minus 15 times 16 squared equal to 238, and the new n is 2 minus 1 equal to 1. Since n is not 0 at this point, we repeat steps 2 through 4. With d now equal to 238 and n equal to 1, the quotient of 238 divided by 16 to the first power is 14. 14 is represented by e in hexadecimal, and so far our answer is FE with only 1 digit left to fill. The new d becomes 238 minus 14 times 16. That equals to 14, and n is reduced to 0. With n equals to 0, we can proceed to step 5. With d now equal to 14 and n equal to 0, our last digit in our answer is e. Hence, the hexadecimal representation of our decimal 4078 is FEE. And thankfully, this is not a fee to be paid. The skill of converting decimal to and from hexadecimal integers will require practice. I hope you find this video helpful and useful. You can catch my blog at edspy31415.blogspot.com. Thank you and have a great day.